afternoon, good evening, good morning, good night. Let's try now. I don't know if that picked it up. Good afternoon, evening, good morning, brunch time, dinner time, whatever time. We're here. We're about to finish up. This is Architectural 530, Environmental Systems 1, Lecture 11, Sound Isolation. So we are going to do an analysis, isolating sound from one location, our source room, to the receiver room. So let's go ahead and get started. We've got the space. We've got airborne noise in one space. So to the left here, you'll see we've got something making some noise. Going over here, we've got three pathways: ceiling, wall, and floor. We need them to be equal, equivalent, similar. Otherwise, we need to take down the construction of one or the other, or beef it up to match the other two. So we need to find the needed transmission loss based on our level and what our goal target is. Find the lowest SDC path, then the minimum SDC needed for that path, and then upgraded or best option to achieve that. So if we have a receiver room and we're doing NC30, which is a living area, could be a patient room or a classroom, really your basic room that we're trying to meet here. Our source is 72 dBA. We can use that, thinking of it as a acuity to our hearing on there, and it might be the only objective level that we have. So we're just going to use 72 dBA, and we're going to use these single number descriptors in here to get us within the realm, orders of magnitude, see where we're at with either the design, the problem, the upgrade, the modification that we're doing to this space. This would be done in a inquiry. Somebody contacted you and say, "Hey, we have this space. It's too loud. What are your costs for services to address this?" So you could use this to get started in doing your initial report, and then start your programming report where you're looking at what the function of the space is. Carry that through there. Once you get into schematic design and design development, then that's when you would turn that out into more detailed analysis. And that's what we do in architectural acoustics 520 class. So we've got our goal of NC30. We have our source at 72 dBA, and then we've got our construction. We've done some research. We've found that the ceiling is gypsum. It's got an STC of 27. We've got a floor, it's concrete, STC 53, and now we've got a wall, gypsum wall board on metal studs, STC 37. So we need to find out, what do we need, what's the steps, what is the lowest common denominator here, and can we achieve what we need. So we've got a goal of being NC30. We've got a source of 72. That means we've got a needed reduction of 42 dBA. So we need to take out 42 dBA to get down to that NC30 range. If we look at our construction, initial thought is this is going to be well below the 42 that we need. We're 15 below. But what we get is we get a double credit. If we have a ceiling here, it's STC 27 here, and then the sound goes up and through, and when it comes back down, it's STC 27 again. So really this is closer to a 54. It's not exactly linear, but we can use it for that 54. We can use STC 54 in this case. The next one is a concrete slab, and we pulled some information from Kinetics, looked at a concrete slab here, and we get 53. We can see that if we do some sort of topping, we don't get that much, but if we put some isolation in it, we go to 73. So this gives us an idea, but that 54 is well above the 42 that we need. Likewise, two ceilings at 54, or 53 for the floor slab, 54 for the two ceilings, 27 on each side, well above the 42 that we need. So as you're probably guessing by now, it's either the wall is 54 and we're done with this analysis, or the wall is going to be the issue. Now, if we look at the wall, what we found, we couldn't confirm it, but we're going to go with the basis. This is a lower end fit out. Let's say it's a mass produced housing aspect, and they wanted to save money by spacing out the studs and making them smaller. So they're at 24 inches on center, and they're 1 and 5/8 inch studs. That gives us a STC of 37. So that's kind of lowest. That is the lowest common denominator, and we need to get that to 42. We're only off by 5, but that 5 could be a big deal, as we're seeing. So we've got the ceiling at 54, the floor at 53, and the wall at 37. So we're going to work on fixing the wall. Our needed reduction is 42, so we need 5 more reduction due to transmission loss at the wall. We've got some different options that we can look at. We can stay with the same type of construction, and we're going to look at some types and why. You might be asking yourself, this 24-inch on center, smaller studs, why are we using that? Because if we look at 16 inches on center with bad installation, not installation, insulation. So 24 or 2x4 studs, 16 inches on center with 5/8 inch gypsum on each side. We're still only at a 38, so we're not even where we need to be. So any of these constructions here, while they're less efficient, or they're better constructions compared to this lower cost construction, from an STC standpoint, we're not getting too much out of it. So we can't say we're just putting insulation in the wall or doing wider studs and using 5/8 gypsum on each side. We could be as low as 34, and we could get as high as 39. That's about as far as we're going to get, but that's still not our 42. So this 37 isn't that big of a jump, even if we haven't verified that. So we don't even really need to cut a hole in the wall and do a site visit analysis and confirm what it is. We can go off of this assumption. Now, if we do a staggered wall, same 2x4s, but now we've got a 2x6 plate on the bottom and we stagger the studs, we can get anywhere from 42 to 49. And this is the realm that we need to be in. We need a minimum, the offset wall. So at a minimum, we should use this offset wall here. That gets us our 42. But remember, that's best case laboratory. Laboratory testing. We want to knock 5 off of that. So we could use this 46, this middle wall. It's very similar. These two are very similar. What this has is a different type of gypsum on it, a type X gypsum board. So if we use this, took 5 off, we'd be at 41. We'd be close. We don't really want to be close, right? This would be good enough. This wall would be good enough for government work, but hopefully we're not doing all government work. We're doing very high profile projects that we all love for the masses, and we don't have budgets that we're constrained by. We're giving them the best solution. So we're going to go with this 49 option here. We take 5 off of that, we're at 44. We're above where we need to be. But even then, this 49 wall is not equivalent to the other. Remember, we got 53 and 54. So it's going to be really hard to get a gypsum stud wall up to 54. We can add some more layers, but it's going to be expensive. So now we can look at it. If we're good on the walls, we might be able to have a thinner slab or a different ceiling type on there and be able to save money there. So the money that we spend here on the wall, upgrading this low-end wall to a better performing wall, we can then take those expenses, take it back to the floor, the ceiling, and do a value cost savings there. And so maybe we improve the wall, change what the floor is, and that cost offsets it, and then we have a much better acoustic environment. So we've got our needed reduction is minus 42 dB. Our weakest point, our lowest STC path is the transmission through the wall. The minimum wall type we'd want to use is the 42 STC. And then the recommended wall type we'd want to use is the 49, the one with the 2x4 offset, 2x6 plates, X type gypsum, and then some insulation in the wall. That's it. That's how we figure that out. That's where we start to build cases for why we're choosing finishes, why we're choosing construction type, and how that affects the room. Pretty quick, pretty down and dirty, but by this point, we've got a good understanding of these principles. All right, that's it. I will see you on the next lecture. Stay frosty out there in Radioland. Unless it's already cold, then stay warm.